Hey team, just loading up. Hold on. All right, just doing a quick sound check, team. Are we good to go? Okay, I'm in Harvard. Okay, well, all right. I just need to know if we're good to go. Can you guys hear me? Is my sound working? All right. First things first. Just letting you know that yeah, my printer is running non-stop. So if the noise is too much or too annoying, just let me know. I can pause the printer, but it's running for another 37 minutes. So yeah, just the noise level might be there for another 37 minutes. Okay, so we're gonna get started for oh, did I put wrong date? What did I put? Oh, 4th of November. Right, I see what happened. Typo, I'll change that. There we go, that's better. Yeah, we all wish it was 4th of November. All right, so we're going to get started with the usual. I'll do a couple of merit questions, and then we're going to go straight into excellence questions. So, looking at the first merit question. By the way, this is... I forgot to mention that this is actually Cohere 2020 again. So just a good selection of questions. All right, we started with that first one. Matt Pauling, I think you can basically, I wouldn't recommend it. Like, you've got to show some sort of integration for that. Yeah, you got to do some sort of integration for that. V, we're doing integration today. Prajwal, we'll start on Monday and we'll go for the next 3 days after that. So we'll go from Monday, Tuesday, Wednesday, all right? Yeah, Prajwal, we'll probably start with Monday, and then I think we should have enough time to go through it till, what do you call it? Till Wednesday. I think your exam's on Thursday, is that correct? I'm sure it's Thursday. So, what's the bracket rule, Ben? Get out of here, J. Crow. No way, Evian. I think I've done all of that. Bring the power up by 1. Yeah, that's right, Ben. I think you got. Yes, Nee. I've already done complex numbers. I did complex numbers on when was it? Thursday, I think it was. So yeah, and then differentiation last night, and then tonight doing integration. I think tomorrow we're gonna call it, because usually people will actually just want to do their own revision. All right, let's go through this question. Enough time there. So what we've got is just, you've got your normal integration here. So that means we've got dy. We don't really need to do anything, except I'm gonna rewrite this as Square root, so it's going to look like this first. And before I even integrate it, I'm going to write this as x plus 3 to the power of negative half. And then from there, what we're going to do is we're going to integrate this. So when we integrate this, we add 1. So y is equal to x plus 3, negative half plus 1. And of course, divided by the new power, which is negative half plus 1. So what you're going to end up with is y is equal to x plus 3 to the power of half, and then that's going to be divided by 1 over 2 plus c. So we've got x is equal to 1, y is equal to 5. Sorry, Andrew. 5 is equal to 1 plus 3 to the power of half divided by half plus c. So we've got 4 to the power of half, which is 2. 2 divided by half is 4 plus c. Therefore, c is equal to 1. So you got to write your equation up. You got x plus 3 to the power of half over half plus 1. All right, so let me know if you have any questions with that. It's all right, Nikki. I thought you were level 2. Are you in level 3? Nah, Tommy. This is a merit question because you're doing a couple of steps here with this differential equation. If it was just asking you just to integrate, it would be achieved. But because they are asking for the actual question, no worries, you're welcome. Foghorns, there's a rumor it might happen tomorrow because I'm not going to do calculus tomorrow. All right, let me see if I can find another quick merit question, and then let's see. Oh, this is a good one. Question 2D. This is the other one that always seems to come, right? So I'm gonna put this one up here. All right, here is the next question, another merit question. Oh, that's a good merit question, actually. I don't. What's Evian? I don't know. I'm just gonna do a few questions, and I think because it's the last night, we're gonna be doing level 3 calc. After I finish the 3, see if I can find some more crazy questions that we can do. Reverse product rule. I mean, you can use it, Jacob, but like you just gotta be careful. Not reverse product rule. Sorry, reverse chain rule. I'm thinking. I think the grade cut score is always gonna go. It's cut scores always differ, guys, because like you won't be able to tell because in like some years they make it 19, some year they make it 20. So it's a little bit you can't really guarantee on that. Nah, I won't do scholarship because I got another good mate of mine that's doing it. Ah, sorry, Nikki, I didn't realize. Well, yeah, it's been doing it Thursday, Friday, Saturday. His name, he goes on YouTube as Calc WLD. Calc WLD. Look up his YouTube channel. He's good, man. Fair enough, Nikki, fair enough. All right, so if you don't know how to do this one, what you need to do is think about it like this, right? So firstly, you can do it two ways. I mean, you can actually figure out what the area is, and then well, we can't actually figure out what the area is because we don't know what k value is. So what we do know is this graph here is x squared, this graph here is x cubed. So if we were to write this as an equation, remember this is going to be k and 0, and what we're going to do is we're going to go top minus bottom. So whatever the curve on the top is, that's going to be ending up there, and then we could go minus, but what else could we do? That's one way of doing it, and you can actually put it equal to k to 0 of x squared, because this top minus bottom part here is going to give you all of this area here, and then the green the green part here, that's all of this thing here. So you can actually put that both equal to each other. What am I missing, Jacob? Yeah, okay. What's wrong with k is less than 1? I mean, k can be less than 1. There's nothing wrong. That's one way of doing it. The other way of doing it is you could actually go oh, k is less than 1. Sorry. Yep. Okay. I see what you guys are saying. Apologies. If k is less than 1, x squared will be above. Yep. Makes sense. Because if k is equal to less than 1, then x cubed generally will be so. Yeah. Sorry. Mess. I was wondering what you guys were on about. And I'm sure I got that wrong, but okay, that's fine. So we've got k and 0. So in this one, we're going to get x squared minus x cubed is equal to k and 0 x cubed. The other way you could do it also is you could also say, what else can you say? We could also do it like this. K and 0 for x squared is equal to 2 times k and 0 of x cubed. Ishmeet, the reason why x squared goes to the top is because let's say k is equal to, I don't know, 0.9 for example, right? If you take k as 0.9, if I do 0.9 squared, that's going to be 0.81, but 0.9 to the power of 3, that's x cubed, that's actually 0.729. So what happens is it's actually underneath the x squared graph, if that makes sense. If I was to draw it, let me show you this one. Add source. So here is the other reason why. So if I do x squared so notice how the blue curve is x cubed. So when k is less than 1, because k is less than 1 means that's like we're looking at somewhere here. So the red one is always above the blue one. Ben, I just use 0.9 as an example because as you can see, at 1 they meet together, but before 1 the blue curve is always underneath the red curve. The red curve is the parabola. So that's why the parabola x squared goes on the top. So that was just an example there. All right, so next we're going to kind of work this through. So we've got integration of k squared. So that, not k squared, x squared. So that's going to be x cubed over 3. That's between k and 0. Equals 2 times x to the power of 4 over 4. And that's between k and 0. So we don't need to worry about the 0 part. So we can just substitute k cubed over 3 equals 2 times k to the power of 4 over 4. So we're going to get, well, it's actually quite easy because you're just going to get 4 over 6 k to the power of 4 k cubed. So k is equal to 2/3. Dear, it's where did the 2 come from? Because it actually says that the two areas, the green area, which I've highlighted here, and the yellow area is actually equal. Now, if you think about it, when we calculate for x squared between, ignore this equation, all right? So let's forget about this equation. If you look at this part here, what it does is it's actually calculating all of that area there, right? So if you look at the pink part, this part here is calculating that. The orange part, actually not the orange part, the orange part is actually calculating, I don't think you can see it right. It's calculating that gray/green area. So all it is just getting multiplied by 2. That's why I get 2 times the green area equals the whole area. If you were doing the top method, it's pretty much the same thing, guys. Because look, if I was to do the top method, I would get x to the power of 3 over 3 minus x4 over 4 equals x4 over 4. All of that is between k and 0. K and 0. So what you end up with is k cubed over 3 minus k to the power of 4 over 4 equals k4 over 4. Then I'm going to get k cubed over 3 equals k4 over 4 plus k4 over 4. And basically, I end up in this line here. I don't think this calculator, Sarah, I don't think you can actually do this question in the calculator because it's actually asking you to figure out what the k value is. Are you trying it in Solver? Alex, the 2 comes from like this. Look. So this is the yellow part, right? Which is the x squared part. The green part is actually underneath it. And if it, what the question's actually saying, but there's a split here. Like the split is, so imagine like this green part actually fits in here. So the area, because this area equals to this area, we can say that this part is going to be double that of that. Yeah, k equals to 2 over 3. Pip, I did cross multiplication. So 4 came here, k cubed came there. Both of these questions are merit. No, you're not, Mercy. 6 came from here, 3 and 2. Alex, in this question, because it said the two area is equal to each other, therefore that's why we can actually say it's double the area. So you've got to kind of look at the question and go, like, imagine like this. If I tell you, if I have a box and say if they are equal areas, right? So this is, say, imagine this is 5 and 5. What we can say is the full area equals to 10 and the box is equal to 5. So that's how I get the 2 from, because 10 is equal to 5 times 2. So that's kind of the idea that I did here. That's why the area got multiplied by 2. All right, team. We're going to move to our first excellence question. As I said to you before, these excellence questions are a bit like crazy at times, but sometimes they're okay. Because the paper that I've been working with, it's like, yeah, it can get a bit nasty. But anyway, all I have been given for this excellence question is this. I feel like we're going to move on. Now I'm looking at your what you're saying, Alex. Alex, I think, like, I'm trying to explain it, but it's like the white area is only showing, like, you have to think about it like the whole thing, right? The whole pink thing is 2 times the green part or 2 times the yellow part. But to calculate the pink thing, we have to go between k and 0 for x squared. No, it can't be more, because it's actually, it says it's equal. Because it's equal, we're going to double it. All right, team, I'm sorry, but we're going to move on to the next one, because otherwise we're going to be getting stuck on these questions for a long time. But yeah, feel free to chat on YouTube, because I know there's a few guys that are explaining the questions a little bit better, Pip. So if you want to jump over to YouTube, there's a lot more explanations there. But Alex, remember that for the previous question, would you just add the 2 to the grade and make it equal to the white area? No, not add, you would multiply it. Ishmeet, what's your equation? Let me have a look at your equation. Throw the equation up and I'll tell you if you're on the right way. And I think that's the problem with most of these questions, right? You just want to know whether you started it correctly. I think it's more Skullcal professional. No, not. It can't be square root of k, because it actually says the directionally proportional to the square root of the current population. So then you would write this. So this is how you'd start it. dp dt equals, it's directly proportional to the square root of current p. So square root of current p, and the k goes in the front. Yes, Alex, that's correct. So when you add the 2 in front, you're actually multiplying the area. Oh, by the way, this is an excellence question, and it's a simultaneous excellence question as well. Just giving you a heads up. In this one, what do you mean by proportional? Like what I've written, that's enough, Jacob. You do need to show that, because you need to show that before you start integrating. You can't just put directly p equals to ae kt and then kind of go with it. I believe it's asking for 12 days after start. So you've got t equals to 3, t equals to 12, and the question's t equals to 10, and the question's asking what is t after 12. That's correct, dear. You've got it. Faizan, we did that at the start of this session. You know how we did square root, change it into power of half, and then you should be good. At the moment, it is k. K is just a constant, yep. 2p to the power of half, kt plus c. David, start substituting t equals to 3 and t equals to 10, and you can set up a simultaneous equation. "100% professional, it's possible." You can do anything, man, these days. I mean, if you're willing to learn, you can pretty much do anything. I mean, nobody would have taught, like, I never thought I'd be streaming on a Saturday night, but here I am. I thought I'd stick to teaching and just finish on a Friday and don't do any work in the weekend, but Kaputan, it's on Monday. All right, we got two. Let me see one more answer, and if we're good, and then I'll start doing the questions. Yes, I'm only doing merit and up. If for any reason, and I know some people are like, I just want to practice achieved questions. If you want to practice just achieved questions, what you can do is head over to my website, because I have organized it in a weird way, but it's there. Where is it? Right, so in my website, under level 3, just go to complex numbers if you're doing complex numbers. If you go to NCA exams, all of the questions there are bookmarked with achieved, merit, excellence. So if you do want to practice, then you could always just go there and do those achieved questions if people are looking at achieved. That's, yeah, literally a ton of questions there for you to try and do. That is if you are trying to do some practice questions. Yes, you can, Brayden. Okay, so I'm going to start doing this question here. So we're going to bring p across to the other side. So that's going to become square root of p equals k dt. Now I'm going to integrate both sides. I've got p to the power of half in the denominator. So when I bring it to the numerator, it'll become p to the power of negative half equals k dt. So I'm going to get p to the power of half, because I'm adding 1 to the minus half, divided by half equals kt plus c. So my equation is 2p to the power of half equals kt plus c. Now what I'm going to do is I'm just going to rearrange this. I'm going to write this as p to the power of half equals kt plus c. I'm going to put that as over 2, and then p is equal to kt plus c over 2 squared. So I'm going to get p is equal to kt plus c squared divided by 4. All right, so once that's done, now I just need to do substitution here. So I want to write this as, well, is there any way to do this without actually messing it up? I'm trying to see if there's a shortcut to do this. I'm trying not to expand quadratics. kt squared plus I'm stumped. Like, what am I missing here, guys? Help me out. Because I know you can do simultaneous. So if I do 182.25 equals 3k plus c squared over 4. I got that. And then 1722.25 equals 10k plus c squared is equal to, oh wait, so I have to use, okay, I see. All right, so those are my two things that I've substituted. So t is equal to 3 and p is equal to 182.25, t equals to 10, p equals 1722.25. Yeah, so cross multiply. So if I cross multiply, I'm gonna get 182.25 times 4. That's 729. 729 equals 3k plus c squared. Then I've got 1722.25 times 4. That's 6889 equals 10k plus c squared. I'm gonna take square root of both numbers. So that's 83 equals 10k plus c, and then square root of 729. I thought there was a quicker way to do this. 27 equals 3k plus c, and then I'm just going to use 10k plus c, 27 equals 3k plus c, subtract both. I'm going to get 7k equals 83 and 27. What is it? 2356. Yep, there we go, 56, and that gives me k value of 8. And if k is equal to 8, 27 equals 3k plus c. C is equal to 3. So my equation is p equals 8t plus 3 squared over 4. T is equal to 12. Hopefully I get this right. All right, so 8 times 12 plus 3 is that, squared equals that, divided by 4 equals 2450.25. All right, sorry, I missed a whole lot of comments there. I will come back and have a look. If you do have any questions, I'm going to put up a line numbers, and then we can go from there. Shout out Mr. Ricciardi. Is he actually here? I didn't see him. Oh, sorry. If he is, say hello to him. Sorry if I missed you. It doesn't matter which simultaneous equations you use, as long as you get to the final answer. That's actually fine. Jeremiah, I think you're good with that. Line 24. What happened to line 24? Yeah, there's fireworks and my printer is going non-stop. Trying to surprise my kid tomorrow morning. I'm building a 3D printing a massive Pokemon for him, which he doesn't know about. Line 25, t equals to 12. David, that's from the question, because if you look at the question, it actually asks you find the population after 12 seconds. 12 seconds, 12 days. This is where it's from, David. Find the population after 12 days. You can use solver for simultaneous equations. That's fine, Tiny Gamer. I just did it late. I was a bit lazy. Tom, I think rate of change you mean for differentiation, right? Is it million? Yeah, sorry. It should be 2450.25 million. I don't know if you can put this in solver. I think you can do 21, 22, 23. Oh, no, not that one. From 17 to 23, you can do that in graphics calculator. Kool-Aid Man, you got to tell me which number line you're looking at. You got C as 1.5. Oh, that's interesting. I wonder where did you... I'm not sure how you got C as 1.5. How do we know when to simplify the difference? Just P or just leave it? Because I left it as square root of P and got a different answer. If you left it as square root of P, then you might need to check your working there, Kaya, because I can't answer that without having a look at all of your working, just to see where you might have made that tiny little mistake. Line 9 ZL, I don't even know how to read your name, but line 9, the where I got line 9 from is actually here. That part right there is line 9. Jeez, 100. Okay, this is definitely a E8 question, team. Like, we're not gonna... This is not a E7 gimme. This is a E8. I just subbed into line 4. Yeah, you could do line 4 as well. I see what you're trying to do. Yeah, line 4 could actually work as well. That's probably a lot easier than what I did. Yes, David. If you go to the complex numbers tutorials, you'll find like a section full of those types of questions. It's in the early days of the complex numbers tutorials. Do I need to write the end answer in million? Cody, I should have written in millions. That's my bad. But in reality, would you get marked for that? That would be pretty cruel to be losing 1 point just for getting the million. All right, I think we're good with this question. I am going to go to the next one, yeah? Yeah, it's best that you actually write the what do you call it? All right, now here comes another interesting question. Excellence 1 coming up. I'm going to tell you guys right now, the clue that I'm going to give you is, remember that tan x is equal to sine x over cos x. No, you guys got this. You can do this. You're going to be doing a little bit of, you're most likely going to be doing a little bit of, what do you call it? Substitution in this question for sure. All right. Yeah, U substitution, you'll need to do U substitution unless you see, you can use U substitution for this question, but you can also do it without it as well. All right, I'm going to give you about, I don't know, let's give about 4 minutes. But my first clue to you is, remember, you can't, actually, wait. Let me get you this table, because I know people always go, where's the table? Where's the table? Where's my table at? So just letting you know in advance, you cannot integrate tan, so you have to change tan to sine over cos, because remember, tan is sine over cos. Love it. I was joking with my friend yesterday that I did see an infinity plus 2, but now there's an infinity plus 3. Welcome to the chat, infinity plus 3. Yeah, try dealing with it on a daily basis, Jacob. It's so annoying. Wait, does he have... Oh, man. If cos pi over 2 equals to 0, cos pi over 2 equals to 0... Getting there. I'm going to give you like another 1 more minute. Well, really, because I want to try and get this Pokemon cut. Damn, this filament is hard. Six, 7 fan club. Wow. Where's Jackson's comment? Sorry, I can't see it. No, you can't. No, it's not. Once I start doing it, you guys are going to be like, oh man, that was actually not bad. All right, so let's actually go through this. I got to figure out how to take this apart, but PIs, that's fine. Cool. So let's actually go through this question. Lovely. Okay. All right, so we're going to start doing this question now. I'm going to get rid of this for now because we don't need this chart. But basically, what we're going to do is we're going to start doing this, right? So we're going to go, firstly, we're going to have integral of pi over 2, 0. And I'm going to put this as sine x over 2 divided by cos x over 2 minus kx dx equals to 3.5. So, and the reason why I did this was because if you guys remember, there's one of the rules that we talked about is when you have integral of f dash of x over f of x, dx is just ln of f of x plus c. Like, I hope you guys can actually remember that f dash of x thing. That's a little, it's a little clue that I don't think that's actually given in your formula sheet, but you need to remember that formula. But if you don't remember that formula, then you have to use substitution to kind of get this going. Is it on the sheet? I can't remember it, but let me just have a quick look. Formula sheet, level 3 calculus. Let me just check. I don't, oh, there it is. Yeah, actually, yeah, you guys are right. It is there. Shot, Jacob. Yeah, there you go. That thing is right there. That's the clue that you need. Because remember, sine x is, if you go right to the top, when you differentiate cos x, you actually get sine x. Which means, because sine x is in the numerator, cos x is in the denominator, they're linked, we can write it up like this. So I don't know if you guys want to try this question again. Where is this? How many of these things do I have? So then you could actually write this as negative sine x over 2. Because two negatives make a positive. And then what you can then do is you can actually go, well, what's the next step you could do? You could have that over cos x over 2 minus kx dx equals to 3.5. So because I have this negative sine x over 2 is the f dash of x part, and then cos x over 2 is the f of x part, I can rewrite this as, when I integrate this, this will become, let me just double check my notes so that I don't mess it up. It shouldn't be negative? Why shouldn't it be negative? Because when you differentiate cos x, wouldn't you get sine x, negative sine x? Because look, I mean, when you Because differentiation of cos x is actually negative sine x. Oh, did I make a mistake? No. Now, guys, look. The reason why I have the two negatives there is because when you actually integrate, when you differentiate cos x, so remember, if this was ln of cos x, right? If we differentiate this, we're going to get 1 over cos x multiplied by differentiation of cos x, which is actually negative sine x. So what happens is when you do ln of cos x, if this was that, then y dash would actually be negative sine x over cos x. The problem is we've actually got positive sine x, and because we have positive sine x, we need to we've got to have a negative sine x there, so that when we actually do that, can I not go divided by half x? Wait. Well, Tiny Gamer, what I've done is I've actually added two negatives there, because look, I've added a negative here as well, so those two negatives are actually going to make positive. If you're finding that tricky, yeah, that's right, Simba. We split the positive sign into two negatives. Why can't you have, no, you can't have ln of a negative value, but you can have negative ln of cos x over 2. There's nothing wrong with that. The first step, Sarah, is like tan is sine over cos. That's what I did. So a few people are going, how did I get, because remember, tan x equals sine x over cos x. No, I think it's actually in the formula sheet. Because, where is it? Where's the formula sheet? There you go. Where is, oh, the tan one is not there, is it? I think the tan one you have to remember, but like the other ones are there. All right, let's try another method. Let's try substitution, because I think this one might be like, you could use this method, but even if you don't use that method, I will try and show this to you through substitution. Maybe that might help a little bit. So what we're going to do is we're going to put this as pi over 2. Actually, no, I'm going to leave that there so I can show you how it actually works out. So we are having problems with this right now, but what I'm going to do is I am going to actually do this question again, but this time I'm going to do this with substitution. So we got sine x over 2 cos x over 2 minus kx dx equals to 3.5. I can separate this as pi over 2 sine x over 2 cos of x over 2 minus integral of pi over 2 and kx equals to 3.5. Let me know if that's okay so far, what I've done there. Did I make a mistake? Sorry, that was my bad. That should have been 0. Sorry, typo. This is definitely an EE, guys. This is an E8 question. Right, now next step I'm going to do is I'm actually going to do this part first, but I'm going to use substitution for it. So if I say u is equal to cos x over 2, then du dx is equal to negative sine x over 2 multiplied by the differentiation of the bracket, which is 1 over 2. LK, you don't have to, but thank you. So you got du dx is equal to negative 1 over 2 sine x over 2. Now the only thing that's actually available for the substitution part is we've only got sine x over 2 dx there. So I'm going to rewrite this as negative, so I'm going to go 2 over negative 1 du equals sine x over 2 dx, because all I'm trying to do is I'm going to use the substitution method, but I've rewritten everything there. So I'm going to get, I should really change pi over 2 and 0, but at the moment I'm not going to worry about it. I'll actually bring it back. So that's technically not correct, but I'll bring it back anyway. So what then's going to happen is we're going to get negative 2 du over u, that's it. And when we integrate this, we're going to get negative 2 ln of u. And then because u is equal to cos x over 2, we're going to get that. That's between pi over 2 and 0 minus, we've got to also integrate this part here, which is going to be kx squared over 2 between pi over 2, 0 is equal to 3.5. Now I'm going to pause there because I know that there was a lot to take in that question. So before I get on with the next part of this question, feel free to ask some questions there. Speedy boy, welcome. Tan Basley, I should actually make some more new ones. How to do step 4 to step 5. All I did, Tommy, there was I just brought the half to the front. Line. What is this? Play the audio. Sorry guys, I just have something here. JNL VQ. Sorry, I just had something's up with. Okay, anyway. That's done. No, Evian. There is a shorter way. That's the f dash of x method. Why doesn't using negative sine pi over 2 work? Tom Lad, you got to give me a line number. What did you do in step 6? In step 6, I brought the 2 and negative 1 to the other side. So I brought 2 to there, negative 1 there. The dx I took from this and moved it around. Line 7 to line 8, because I integrated it, sorry, that should have been line 8 there. Because I integrated from line 7 to line 8, and then in line 8 to line 9, I just substituted u as cos x over 2. Vasha, usually what you need to do is when you look at the questions, you can see like one of them is the differentiation of the something else. So I would always go with whatever the item before it was differentiated as u. David, I just separated the function, the two functions. Which line are you confused with, Ashley? Oh, okay. I see what's happening here. Now look, guys, the part is this sine x over 2 in line 6 is the same thing as saying negative 2 du. So I've actually replaced sine x 2 dx in the original function. Like if you look at it, I've replaced this with this in here. And then because cos x, where is that one? Because cos x over 2 is equal to u, I replaced u as cos x over 2. That's the whole point of substitution. Oh, you've never learned substitution rule. Okay, now that's... I'll tell you guys what's a good video to do this for substitution. I think it was... Oh my god, I can't remember. Was it u sub? That's differential equations. Trying to look which one did I do u substitution in. Oh, that's terrible. Okay, u sub is part 6 of this integration in 15 hours playlist. It is worth watching that 6th episode, because that actually covers a lot of the u sub questions, and you can kind of look at how to actually do this. If you were to do f dash over fx, so I will do that here. F dash over fx is basically like this. So you would have had, no, hang on. That'll just be directly negative ln of cos x over 2 divided by differentiation of this, which is a half, and then minus kx squared over 2 between pi over 2 and 0. That's how you would have done it if you had done it with f dash of x over f of x. So I mean, like, I know the substitution one is a little bit longer, but if you're comfortable with f dash of x and f of x, then you're good to go doing that as well. I'm glad we got through that. That was quite painful. Yeah, but you got to have the negative there, Ashley, because the differentiation of cos x is actually negative sine x. So you know the two sine x's will cancel out, but then you still have the negative sign there. So you should have got negative 2, because this is the same thing as saying, because it's dividing by half, this will become negative 2 ln cos x over 2 minus kx squared over 2, and then pi over 2 and 0. And all of this is equal to 3.5. All right, now we haven't actually figured out what the k value is. I'm just trying to think, is there a way to do this on Solver? You probably have to write it very long, and I think you can do this in Solver. I'm going to do this in Solver. So I'm going to go cos of pi over 2 times 2. So that's going to become pi over 4 minus k pi over 2 squared over 2 minus negative 2 ln cos of 0 minus 0 equals to 3.5. Now, cos of 0 is 1, ln of 1 is 0, so that part just becomes 0. So you've got negative 2 ln cos pi over 4 minus k pi squared over 4 over 2 equals to 3.5. Yeah, you could just chuck it up on solver. I'm gonna put it on solver because I can't I can't be stuffed doing this. In a nice way, in a nice way. All right, so we've got negative 2 ln cos of pi over 4 minus, okay, I'm gonna put that as x, brackets, we've got pi squared over 4 divided by 2 equals 3.5. There you go. Negative 2.275. Now this part, yes, you can actually use the calculator for solving. They're not going to expect you guys to show the working out for every single detail here for this part from here. Kool-Aid, we have done questions like that before, so yeah, I know. Fires, it does the, I think the original one works as well. Zathora, I think that's I was just being lazy because I could have changed the upper and lower limits, but because I knew that I was gonna come back from u back to cos x over 2, that's why I didn't bother changing the limits. David, to use it, just go into equation. Go into equation and then click on solver, F3, and then you type the equation, but you use equals from shift full stop. Jacob, for 7, like I said, I was mentioning before, like because I kind of just I did that separately. I didn't put the limits. Like I could have done it in the back of the book, for example, like back of the answer booklet, for example, and just gone straight from this, from like line 1 to, from like line 2 to line 9. I could show them as part of working, but I could have done the u sub in the back somewhere else, so I wouldn't be worried about it. V, I feel like you forgot the minus in your equation somewhere. It should be minus 2 ln cos. Uh, 6, Tom. It was 6. Part 6 was u substitution. Shot all spin, thank you. U sub questions is part 6 of the integration playlist. Deborah, we're doing these questions from Cohere 2020. So it's a different, these questions tend to be a lot different. All right, team. So what we're going to do is we're just going to take a quick 5-minute break. We'll come back at 9:30 and then we'll do another couple of questions, yeah? Seriously, yeah, 9:30 we'll be back. Take a break. Oh, do we need to test the value? Why, J. Crow? Why? I'm sure it'll work. Jay Brixton, I would actually do more papers rather than watching the skills. I gotta figure out this. I just need a 2-minute break and I'll be back. It can't be 9:30 already. The hell? How does this work? Oh man. Does anybody want to have a guess at what Pokemon I'm printing the kid? Damn it, Gilscore, how did you know? Gilscore gets it on the first go. I'm up to here. Oh, wait, you can't see it. Hang on, let me just show you. This is gonna be like. Oh, you can't see. There you go. I've just built the top part of it, and I gotta print the body next. Oh, he's obsessed with it. He's obsessed with it, and I was like, okay, fine, I'm gonna make it. Which one? So yeah, like look, it's starting to take shape. I gotta do that tonight, so I'll finish it after the stream, of course. I'll finish all the base, but the body still needs to be print. Oh yeah, I've been printing these guys as well. So yeah, like it's amazing what you can print these days. Maybe I should make an Infinity +1 Labubu, right? That would be hilarious. Actually, it's not a bad idea. Shouldn't be that hard to put an Infinity +1 logo on it. No, I made a whole stack of them. Sorry, getting distracted here, but I'll show you the ones I made today. So these were the ones that were made today. I was messing around. There you go. That's this one here. The third one. You can kind of see it. Dude, 3D printing, it's good fun. All right, let's go. Next question. Now, I was having a look at this particular one because like the excellence question kind of was like, it was a bit weird. So I'm going to pull up another one. Let's just see. Where is it? What year is this? 2015. Ooh. 2015 were horrible questions. Nah, David, not tomorrow because it's... Give me a second, mate. I'm just going to open... No, it's not too bad of a question. Let me just see what question I'm going to pick up for you guys. Oh, that does look horrible. I've got one more excellence question for integration. Which one do you guys want to try? What's a CRT? I know we're doing an E1. Don't worry, RAR. We can do 1 Newton's law of cooling, you reckon? 1, 2, 3, 4, 5, 6, 11. Number 11. Yeah, Newton's law 1. Okay, let's do a Newton's law 1. Just get that out of the way. Okay, coming up, Newton's law of cooling. So 1. There we go. Interesting. 2-part question. Cool. I'm going to put that as, I think we need at least 5 to 6 minutes for this question. Oh, maybe 4 minutes. Nah, definitely not that, Jacob. Oh, CRT, conjugate root theorem. Sorry, I was trying to read that and I got distracted. CRT, and what was the other question he asked? Like somebody was asking CRT and DMT, and I was like, oh, is De Morris theorem. Oh, De Morris theorem. Yes. Okay, I understand. It could be CRT. I don't know. Could come in. I don't know. I can't really sit here saying that I know what questions come and go. What's the odds of that? Considering, did you guys get a Newton's law of cooling last year? Yes, you did. 2024, you did. 2023, did you get one? You had a rate of change one. '22 was shaded area. Yep, that's another kind of like, maybe. I don't know. I can't tell. I don't know, Susanna. Okay, so I'm going to go with the original part of the equation first. I mean, so if you look at the first part of the equation, takes it to the room that's actually 17 degrees temperature. So write a differential equation. So it's going to be dt over little t is what we're going to get. Negative k, because, and again, it doesn't matter if you put negative k or positive k, because what would happen is it will automatically adjust as you find the values. But what does matter though is this part here. So we do have to write it as t minus 17. So that's the opening part of this question. Now it actually says when the hot lemon drink is poured, it is 97 degrees. So when t is equal to 0, big T is equal to 97. When t is equal to, well, we can actually go with, yeah, we can go with 3 minutes. So 3, big T is equal to 68. Must drink the hot lemon while it's between 48 to 56 to help him feel better. Yeah, so we're literally looking for 2 times here between 48 and 56. So it's actually not too bad. I mean, it's just got to work out the 2 times. Pink Ninja, that's something you just have to remember. Like I do that in episode 13 or 12 of the integration playlist. There's a couple of formulas that you just have to remember. And I think once you remember those formulas, you are pretty much good to go after that. No, ohm, you can use seconds if you'd like. That's not a problem. Because just understand that if you use t as 180, then your answers will come in seconds. So I don't think that's going to affect your answer in any way. You might get a different k value than us, because when you use t equals to 3, the k value that you'll get is completely different as in when you use 180. Look across that 4.79 minutes. Yep, that's great, but we've got to make sure you give that in what do you give that in minutes and seconds? Either, David, you could use either. You could use 180, but you'll end up with a different k value, but your final answer still would make sense. If you do 3, then you'll get a different k value, and again, it doesn't matter which value you use. Now, while you guys doing that, I'm just gonna need a little, what am I missing? Missing the black dot there. How long is this going to take to print? Okay, all right, I'm going to go through this because you guys are starting to kind of get a few answers in there. So basically I need to solve the differential equation first. So I'm going to have dt over dt is equal to negative kt minus 17. I'm going to bring the big T down to the denominator, equals negative k dt. Then I'm going to integrate both sides. I'm going to get ln of t minus 17 equals negative kt plus c. At this point, what I'm going to do is, actually, no, I'll do this as like this. T minus 17 equals, at this point, you can just jump that step. So you could just write this as a e negative kt if you want. So from here, our t is equal to, little t is equal to 0. Big T equals to 97. So we got 97 take away 17 equals a e 0. So then a is equal to 80. I'm just going to keep going here. So our next part is when t equals to 3, big T equals to 68. So we got 68 minus 17 equals at e to the power of negative k times 3. So 68 take away 17, that's 51. So we got 51 equals at e negative 3k. So 51 over at equals e to the power of negative 3k. And what we've got is ln of 51 over at equals negative 3k. And then k is equal to ln of 51 over at divided by negative 3, which equals to whatever this is. Thanks, J. Crow, for that. I know I jumped a step there. So I'm going to do ln of 51 over at divided by negative 3. So k value is equal to 0.05. Oh, sorry, 0.015. Yeah, the next one is too far, I don't care. Just leave it like that. Okay, so I kind of have used up this space here. So now I need to go... I need to figure out when it's 56 and when it's 48. So I'll do the 56 first. So 56 minus 17 equals 80 E negative 0.15 T. So doing this, 56 minus 17, 39. So I got 39 over 80 equals E negative 0.15 T. So ln of 39 over 80. Sorry, I'm just going to, actually, I won't. I don't want to confuse people. So then T is equal to ln of 39 over 80 divided by negative 0.15. So the first one that I'm going to get is ln of 39 over 80 divided by negative 0.15. So that's 4.79. The next one is 48 degrees. 48 minus 17 equals 80 E negative 0.15 T. Now, because I know that 48 take away 17 is just 31, I'm not going to waste my time doing all the steps again. Instead, what I'm going to go is into the calculator, and I'm just going to get rid of the 39 as 31 because I know the rest of the equations are going to be the same. So then I can just kind of do this. T is equal to 6.32. Now, the question is asking also how long, also find out how long Frank has to finish his drink. So if you look at it, we've got 6.32 minus, so we're going to do 6.32 minus 4.79. That gives you 1.53. So we first need to say when does he need to start drinking. So that's at 4.79. So if you do 4.79 into time, so it's 4 minutes. So we're going to get 0.79 multiplied by 60 is 47 seconds. So should start drinking at 4 minutes and 47 seconds. And then he's got 1.53, so 0.53 times 60. And he's got about 1 minute and 31, well, probably 32 seconds to finish drinking it. All right. I will check the comment section. Sorry, let me put all the line numbers here. All right, what have I missed here? Love, you save me. No worries, Aston. You're welcome. Cody, that's correct, but you've got to change that from 4.8 minutes to actual time. Okay, I've got no idea what that means. Which part? How do I know which t value for which? What do you mean, which t value for which? Guys, if you look at the question's actually saying, Mary tells Frank he must drink while it's between 48 and 56 degrees. And the question's asking how long since it was poured that Frank can begin drinking. So he's supposed to drink between 48 and 56. So I'm putting 56 here to figure out at what time he can start drinking it. And then at 48, when he needs to stop drinking it. Rara, you could use that, but the problem is, like, because we have the original temperature of 97 degrees, it's much better to do it with AEKT because you can substitute it straight away. Otherwise, you need to write that as that C value as ln of 97, and can get a little bit confusing there. Taring, yes, you do need to convert it to minutes and seconds because the question's kind of asking how long since it was poured. I mean, I guess you can say it as between 4.79 minutes and 6.32 minutes. But I'd probably put that as, yeah, I still need to convert that into time. Did it yesterday, Yuffie. Swag Gaming, that's your original differential equations integration. So I think we've done a lot of the previous questions. So if you're struggling with that, have a look at episode 13 or 12 in the integration in 15 hours playlist. I'm actually, I think, converting it to time, because you know how it says like 1.5 minutes. If I say 1.5 minutes, that's 1 minute and 30 seconds. So all you do is you just go 0.5 times 60. That's going to give you 30 seconds. So if you have like 1.79 minutes, you would go, that's 1 minute, and then you'd go 0.79 times 60 would give it to you in seconds. So the 1.79 is 1 minute and 47 seconds. Line 3, I guess line 3, I did do it a little bit faster, but like from line 3, what could have happened is like t minus 17 equals e to the power of negative kt plus c. And then t minus 17 equals e to the power of c e negative kt. T minus 17 equals ae negative kt. But those 3 steps you don't have to actually show in your exam. You can go directly from like line 3 to line 4. Simba Gaming, the T in 18 and 20, that's when the temperature is between 48 and 56. So when it's 56 degrees, the time is 4.79. When it's 48 degrees, the time is 6.32. So that's how long the time has gone past for those temperature, when that coffee or whatever the drink, lemon drink, reaches that temperature. If you were to leave it in decimal, I mean, I know we're getting into semantics here, but ideally, yeah, ideally I would probably put it in minutes and seconds. FJ12, I think it's either episode 12 or 13. Correct, Ashley. 4.79 was from, so after 4.79 minutes, the temperature of the lemon drink reached 56. After 6.32 minutes, the temperature, what the hell? I kind of missed that. I don't know where that was. Pine, we're doing integration, so when you do integration, the dt's will disappear. Little t is time, and big T is the temperature. All right, Said, I'm sorry. That's where does the 1 minute and 32 come from? 1 minute and 32 comes from 6.32 minus 4.79. So if you do 6.32 minus 4.79, you actually end up getting 4.79, not 4. So you get 1.53, and then 1.53 minutes is actually equal to 1 minute and 32 seconds. Now it's, I mean, like, it's the rate of change, like, not rate of change, differential equation question with like these things is good to have in your back of your pockets, because it's like sometimes if they do come, they are pretty straightforward excellence questions. So yeah, I would say it's worth knowing, but there's nothing that's guaranteed that it's going to come or not. That's right, Brightax. It probably is going to be. Sky, I'm not sure what you mean by exponential method and substitution method. Correct, Ashley. That's correct. Yeah. Well, I mean, Alex, when you're answering the question, yeah, I think I'm being picky here, but I mean, you might get away with 1.53 minutes, but generally speaking, when we say 1.53 minutes, I don't know. I'm just being picky here. That's all. All right, let me just have a look. Mm, 2015E. Okay, we ready to do one last question for the road? One last excellence question. Or are we done? One more. All right, let me just have a look at this one. Okay, this is actually a good question to finish on for integration. This is the last one, team, for the night. And for some of you, this is the last one. All right, so here we go. It's an annoying question, this one. This one is from, yeah, it's an area under the curve excellence. This is from 2020 Cohere. It's an ugly question, man. Like, seriously ugly question. This got a hell of a lot of algebra in it. That's all I can say. Pine. No, that's going to become ln Pine. Sorry, I'm just kind of... The x-intercept is 2. Yes, sorry. The x-intercept there is 2. I'm just trying to figure out if there's a quicker way to do this than to do this the method that they actually showed. Yeah, we got to find K. You could use U sub, but I don't think it's gonna help you in any way in U sub in this case, Ishmeet. It's just a miserable question. I think this is the worst question to finish for you guys. Almost like I felt like I shouldn't have done this question. Ugh, this is gonna be a long question. I'm trying to see if I can figure out a way to do this in a shortcut method, like, because sometimes they just make things so difficult. 2 to 0. Equals 0, that would work. Oh man, this is gonna be yeah, Sanvi, we're gonna come back to level 1 on Monday. Yeah, try it, Ben. So team, if you're willing to kind of go, where do I begin this question? I think it's just an ugly question, but it's a big question. It's literally this. X plus 2 to the power of half minus 2 dx is equal to 0. Now, you don't need to find the area at all in this case. I think you're just trying to figure out what the K value is. Because, Tommy, it actually says that the area between K and that value equals to 0. So we can kind of assume, I mean, I don't think we don't need to find the area at all. It does cancel out Tate, but the thing is you still need to figure out the K value for it, which it cancels out. I wonder if there's an... No, either way you do it, it's gonna end up looking an ugly equation. Definitely June Dreams, yeah. Is it 4.1871? Oh, we got a couple of people with the right. Yeah, you're on the money there, Noah and WSG. Correct, Chetila. That should work as well. I was actually thinking about doing your method, Chetila, because I was thinking about finding it between 2 and 0. Find the area under the curve first, and then put it to between K and 2, but the positive version of it. But I think either way you do it, you're still going to end up with a very ugly equation, no matter which way you do. Oh, true. I love it. I love that idea, Noah. Yeah, of course. Gil score. All you got to do is you just got to figure out the integration part, and then you can put it in solver. That is epic. The problem though is do you need multiple solutions? Does solver give you all of the values, Noah? Oh, sorry, Kilsco. It gives you just the 4.187. Ah, that's right, because it only gives you one value. Right, then if you find just one value of k, unfortunately, Noah, that's going to be only up to a merit, because for an E7, you need to actually find all three values of k. Pine, you have to understand, we are literally at the final stretch here. We're doing some of the more craziest excellence questions ever. So you've, if you're jumping in for the final part of it, it can be quite tricky. But what I would say to you is that if you go to my website, which I have kind of chucked it up here, let me just show you. Go there on my website, go to level 3, and then you should be able to just do the questions based on the level that you feel comfortable in. And I think even the excellence questions in these ones, they're not too bad. But the excellence questions that I'm doing right now, they are crazy excellence questions. So just going to give you a big heads up about that. Nah, Juntrines. All right, guys, I'm going to do this question because it is going to take me a bit of time to kind of work through. All right, so the first thing is, I think everybody is okay with that first part there, which is just integrating it between that. So slowly working this through, I am going to get x plus 2 to the power of 3 over 2 over 3 over 2 minus 2x. That's between k and 0, and that's equal to 0. Just want to double check that. Minus 2/3 minus 2x. .94 negative 9.4. Pretty much, Chetila. All right, so the next one is I'm going to substitute it. But before I substitute it, I'm just going to rewrite this as 2x plus 2, 3 over 2 over 3 minus 2x. Sorry, guys, I'm going to start working on this. And let's see how this goes. So first I'm going to substitute k. So that's going to become 2 k plus 2 to the power of 3 over 2 over 3 minus 2k minus, now the 0 part of it, so that's going to become 2 3 over 2 over 3 minus 2 times 0, that's just 0, equals to 0. So just double checking, 2 over 3, yep, that's all good so far. I'm going to leave all the k's on one side. I've got 2 k plus 2 3 over 2 over 3 minus, should I make this 6k? No, let's not do something silly. Minus 2k is equal to positive 2 over 3 times 2 to the power of 3 over 2. All right, so next thing is we're good with that so far. I want to combine the 2k. Just checking everything here. I'm actually going to get rid of the 3 there by making this 2k into 6k over 3. Okay, so that means I'm going to have 2 k plus 2 3 over 2 minus 6k equals 2 times 2 to the power of 3 over 2. Now, Ben, I think if you use solver, you only get one solution, and this question has 3 solutions. It's a bit annoying, but we've got to try and figure that out. I just want to get rid of the 2 times 2, 3, 2. I want to see if there's another way of writing this. Okay, 2 root 2. So I've got 2k plus 2, 3 over 2 minus 6k equals 2 root 2. Now, somehow I've got to get the k by itself. So what can I do here? I'm going to get rid of... I'm going to factorize this 2 out, which means I'm going to get k plus 2 to the power of 3 over 2 minus 3k equals 2 root 2. Now the 2's cancel out, so I'm left with k plus 2 to the power of 3 over 2 minus 3k equals root 2. Oh, where did I miss it? Oh, right, it's 4. Sorry. Thank you. Yeah, I did my calculations wrong there. That should be 1.5, not 0.5. Yeah, 4 root 2. So then I'm going to get k plus 2, 3 over 2 minus 3k equals 2 root 2. That's better. What can I do from here? Ben, I think... No, it's 1.5k. That's the problem. If I do this, k over 2... plus 3k. How do I now split this up? Oh my goodness. Now you can't raise it to the power of... If we raise it to the power of 2, we're going to end up with a cube. Yeah, okay, let's try that. Let's put everything to the power of 2, which means we're going to end up with k plus 2 to the power of 3 equals 2 root 2 plus 3k times 2 root 2 plus 3k. We're going to get 4, 2 root 2 times 2 root 2, that's 4 times, I can't do it in my head right now. 4 times 2, is that 8? Plus 6 root 2k plus 6 root 2k plus 9k squared. And on this side, I'm going to get 1 k squared plus 4k plus 4 times k plus 2. So it's k cubed plus 2k squared plus 4k squared. What else do I have? Plus 8k plus 4k plus 8. Let me just check if I did that right. K squared, k cubed, 2k squared, 4k squared, 8k, 4k, and 8. K cubed plus 6k squared plus 12k plus 8. Is that right so far? Let me know. That becomes 12. No, I don't think there's something this hard will come, but it's just... No worries, Simon. Take care. Alright guys, we're nearly there because the 8's going to cancel out each other. And what we've got here is k cubed minus 3k squared plus 12k plus, no, minus 12 root k is equal to 0. And we can take k as a common factor. We're going to get k squared minus 3k plus 12 minus 12 root 2 equals to 0. So we've got to end up with a quadratic now. So we've got k is equal to 0, or these two values here. So we're going to go into polynomial solver, I think it is. No, polynomial. F2, degree 2, and we've got 1 minus 3, and then we've got 12 minus 12 root 2. So there's our two answers, which is negative 1.187 and 4.1871. And if you look at it, k has to be bigger than 2. K has to be greater than 2. Therefore, k is equal to 4.1871. Crazy question to finish. I apologize. It was lots of rearranging, lots of algebra in it. But I think you kind of can expect a bit of algebra with these types of excellence questions. Well, in this case, well, actually, in this particular case, we can say k has to be, because it also says here, k has to be greater than 0, not 2, sorry, 0. See you later, Simba. All right, team, if you have any questions on this, let me know. Otherwise, good luck for your exams. I will, I'm definitely not going to be on tomorrow for calculus. I probably will be doing some distributions, maybe. I don't know. I haven't decided yet. But if I'm too tired, I probably will just sleep. But, yeah, look, I'm hoping, how do I get from line 14 to 15? Line 14 to 15, I just rearranged it, Ashley, like, so this 9k squared, when it goes there, that becomes minus 9. So 6 minus 9 is minus 3. The 8 cancels out each other. And then this becomes minus 12 square root of 2k. Oh, I should have put that equals to 0, shouldn't I? No, that was just expanding the brackets, 13. That was my bad. Oh yeah, I forgot to tell you guys one more thing. Stay subscribed, but switch off all the notifications, because I still want to get to that 100k someday. That was good fun over the last few years. And Monday live stream. Monday we'll probably come and have a chat on Monday night, just very quickly before I start with the level 1s. Chetila, it will be the same thing, but again, you're going to end up with a very horrible equation no matter what happens. I don't know, Vishal. You might come back on Monday for a calc debrief question and see how we go. I know, Durian. It's been like I look back to the last 3 years. 23, 24, 25 has just been insane. I don't know why you would need to do that, V. Oh, the 2k to 6k. I think I just did 6k over 3, because when it had 2k, I just went 2k is the same thing as saying 6k over 3. Oh, that's right. You guys actually did MCAT with me. I completely forgot. Yeah, that was great time at MCAT. You're welcome, Esther. Take care. Eckham, reverse chain rule is a tricky one. That's why I like doing USub more. That's for minions. What kind of language are you guys speaking suddenly? Jack, the question actually says k has to be greater than 0. That's why. I think level 1 is more crazier now, man. Durian, please don't. It's a bit worrying. Lionel, in line 5 when I said 6k over 3, that's just 2k written as 6k over 3. Just because I wanted to have the whole denominator as 3. Tabira, yes, but you've got a bit of... Your clock is ticking at the moment. Rue VLC, yes, it's actually on YouTube, so you can go check it out then. Chetila, my prediction is not next year, probably the year after that, if things go the way they go. The last stream is always a bit emotional, man. It's like, because it's, you know, you get some names that's been here for 3 years and then they disappear. And then some that kind of hang around. No, I don't play Clash Royale. Well, for your level 3s, it is untoasted. I mean, I'll still be here. Bright X, that's the one I 3D printed. I got a whole stack that I printed. Yeah, I think everyone does, Trish. Tabira, yeah, then I don't know. It might be possible. Now, Lucy, I'm not doing calc tomorrow because usually people just wants to do their own study. And if I do a stream right before the exam, it always ends up being, a bit crazy. So I might do, like, if I'm feeling good, I might do some probability or distributions, because distributions, a lot of people have asked. And I haven't had the time to do it. Ishmeet, I will actually think about making it, because you know what? That's such a great idea. Because I was trying to figure out where I can put that logo. Maybe I'll make because I mean I can make the key tags, but I can put like a little logo right there. Should be doable. Need to figure out how. Juntrines, yeah, I'll just quickly do a quick calc recap before I start with the level 1s. Damn, Beggar, you didn't have to, but thank you, man. Appreciate it. Yeah, speaking of merch, I was actually thinking about dropping a few t-shirts after the exams are over. I'm gonna see if I can try and make some t-shirts, and I'll let you guys know. I probably would make like 50 or 60. I don't know. Depends. I'll put a survey out just to see who's keen, and we'll actually go from there. FJ12, to be honest, this is something that I don't see stopping, because no, Tommy, shipping is like 5, because those blimmin' post office people, they charge me like $7. Yeah, as I was saying, these streams, I don't think I'm going to be stopping anytime soon, because it's part of my, like, I feel, I'm just happy to help people. And like, for example, like I'm sitting here right now, there's so many people that's here I've not ever met in real life, but I know I've made some sort of difference for them, and that makes me feel good. So gonna keep doing it. No prob, Susanna. You don't have to again. Jeez. I don't know, Michelle. I mean, like, to be honest, whatever happens, I'll try and help out where I can. Usman, yes, the double time speed. Arigato, Top G. Daisy, wait till Monday, Tuesday, Wednesday when we start doing the tutorials. We'll do some more hard, tricky questions, and we'll have you. Yeah, I'm hoping that you can find it even more easier on that. Fayaz, I am actually working on it right now, so I'm just waiting for the exams to be over. Then I've got a whole lot of Cambridge videos that I need to make. Ben, I do, but not like I think next year I'm going to try and finish the probability in 15 hours playlist for level 3. I don't do Skull Cal. Jaden, you didn't have to. No worries. You're welcome. And M4 Comp, you didn't have to as well. Jeez, guys. What are you guys doing? Stop it. Stop it. Shop, Bright X. Last minute studying, M, just exams. Exam revision. That's all I can say. No worries, Ishmeet. You're welcome, man. Good answer, FJ. Yeah, that is yeah, thank you, FJ. You didn't have to again. Tommy, no Unimath for me. What are we doing, guys? Like, what are we doing with this stuff? Just go get some rest. I've got to print the rest of Greninja. It's always hard to let go on the last stream because you're like, man, I've been here for so long. Greninja update. I'll show you right now. How big is it, Matt? I'm making like a full-sized one here at the moment. Where is the Greninja? Bamboo Studios. Save Bamboo Studio. I cannot find it. Yeah, there we go. Oh, 4 hours and 53 is not too bad. That's the rest of the body. That's the last part I need to print. Daisy, I do like. What was I gonna say? Normally, Daisy, I have. Like anytime I do school visits, Daisy, I actually give these out. Like little key tags. So I have like a whole stack of them. I think I had one in white as well. There you go. More of that. Oh, mean, thank you, man. Appreciate it. You didn't have to. Yeah. All right, team. Have... Ashley, did you win a t-shirt? I'm trying to think. If you did, like in the last one, yeah, I'm going to sell that as part of the merch as well. Why not? When did you win it, Ashley? Was it recently or... Nah, thank you, M4 Comp. I got in... Oh, you got it in August. Yeah, that's when I started doing the 3D printing thing. Now when I do giveaways, I put like one of those key tags in there. Tommy, the last stream for this year is gonna be like on Wednesday night. But yeah, Riri, he does. Right, team. Look, that's basically it from me. I've got to go finish the rest of this. I will catch you guys on Monday just to see how the exam went. Look after yourselves and then make sure you answer every question for the exam. That's the most important one. Don't leave anything empty. And what else? Yeah, no, good luck. Keep me posted, and then I'll ask for some of you guys for reviews on the 15-hour playlist, because that's something that I'm hoping to kind of make it a bit more bigger. But yeah, take care. Appreciate it, Fayaz. You didn't have to again. TikTok, catch you later. Lucy, hopefully a good breakfast that not so good because it just helps you, you know, with release of the slow sugars. But all right, yeah. All the best, team. TikTok, see you later. Tomorrow, I'll figure out what to do tomorrow. I will cancel this. All right, thanks, TikTok. See you later. And live. All right, YouTube. Been lovely having you guys for 3 years, and good luck for the exams on Monday. All right, take care. And Monday we'll have a little review just to see how we go. But other than that, as always, thank you for watching. See you guys.